Damn, the sheer size and density of neutron star material are absolutely mind-blowing. Let's dive deeper into why a tiny teaspoonful would weigh an astronomical 6 billion tons on Earth. Picture this, a star way heavier than our Sun reaching its final moments. Once it burns through all its nuclear fuel, it can't hold itself up against its own massive gravity anymore. The star's core collapses in a catastrophic supernova explosion. If the remaining core weighs between 1.4 and 3 times the mass of our Sun, the Chandrasekhar and Tolman-Oppenheimer-Volkoff limits, it'll collapse even more to form a neutron star. As this collapse happens, the gravitational forces are so intense that protons and electrons in the atoms are forced to merge, creating neutrons. This process basically squishes all the empty space out of the atoms, resulting in an insanely dense object made almost entirely of tightly packed neutrons. To put this density into perspective, the Sun's density. The average density of our Sun is roughly 1.4 grams per cubic centimeter, similar to water. Neutron star density. A neutron star's density is estimated to be around a whopping 100 quadrillion grams per cubic centimeter. This insane density is the reason behind the mind-boggling weight. Even a small amount of neutron star material in a teaspoon holds a massive amount of mass. If you somehow brought a teaspoon about 5 cubic centimeters of this material to Earth, its mass would be mass equals density x volume. Mass equals 1014 grams per centimeter 3. x 5 centimeters 3 equals 5 by y grams. Let's convert this to tons. There are 1,000 grams in a kilogram and 1,000 kilograms in a metric ton. 5 by y grams x 1 kilogram, 1,000 grams x 1 ton, 1,000 kilograms equals 5 by y tons. Hold up, my initial claim was around 6 billion tons. Let's reconsider the typical density range for neutron stars. Some sources suggest the density can vary from 3.7 xy to 5.9 x 1014 grams per cubic centimeter. Sure, the exact number can fluctuate based on the specific neutron star's density, but we're still talking billions of tons for a teaspoon-sized bit. My memory might have been slightly off, but the core idea of unimaginable density leading to unbelievable weight remains true. The immense gravity of a neutron star is also a result of this density. If you were anywhere close to a neutron star, the gravitational forces would be so intense that they'd rip you apart at a molecular level. While we can't physically weigh a teaspoon of neutron star material on Earth, the calculations based on their estimated densities show us a glimpse of matter compressed to an almost unfathomable extent, resulting in weights that defy everyday logic. Before this blows your mind, smash that like button, hit follow, share with your crew, and drop a comment for more mind-bending facts.